Hello everyone, and welcome to this webinar organized by Ceva Animal Health and hosted by VConnect Asia. It's an honor to have you here spending 1 hour of your valuable time with us. The topics that will be addressed now come from very pressing issues for producers, and they are related to reduction of losses associated to respiratory disease. But before starting the technical discussion, please allow me to step back and to recap a bit on the recent evolution of the industry here in Asia. Well, almost 20 years ago, at the end of 2003 to be more precise, high mortality in layer and breeder flocks, in some cases reaching up to 100%, started to be observed in Indonesia, Thailand, and Vietnam. Those were the very first signs of the devastating highly pathogenic avian influenza caused by H5N1 virus, which later spread throughout the Asian countries and caused unprecedented losses to the poultry industry. Today, this is history, but it's undeniable that avian influenza completely reshaped the poultry sector. Among these changes, we could mention the construction of very large farms with environmentally controlled houses, and the adoption of an assortment of new technologies, and most importantly, the implementation of stricter biosecurity procedures. However, these new huge farms, in some cases able to hold more than 1 million birds at once, were built in the same producing areas around the consumption centers, creating very densely populated spots with broiler farms, layer farms, sometimes native broiler farms with distinct levels of biosecurity very closely located. Just to further illustrate this statement, estimations show that today the number of birds produced in Asian countries are at least 2x bigger than 20 years ago. Imagine 2 times more birds being raised roughly in the same areas. Well, not surprisingly, these changes had a direct impact on several aspects of the poultry production. On the positive side, with modern houses, systems, better management, improvement of biosecurity, etc., the flocks now have consistently achieved better performance, and it has definitely contributed to improve the company's productive efficiency. However, despite the remarkable improvement of the farming conditions and biosecurity of this huge concentration of birds in specific areas favors the spread of respiratory virus, such as Newcastle disease and infectious bronchitis virus. Additionally, the recent spread of the H9N2 virus throughout the continent has contributed to aggravate the severity of respiratory problems. Within this context, the profitability of the companies is at stake, and it's critical to find solutions to effectively protect the flocks from these constant threats. So in this presentation today, we are going to discuss new dimensions of the protection induced by vaccines against the 2 of the most challenging respiratory disease in the region, infectious bronchitis and Newcastle disease. To start this discussion, I would like to invite Dr. Christophe Casabon, the Scientific Director of Ceva Animal in France, to present some recent data on decrease of virus transmission thanks to a vector ND vaccine. Dr. Casabon, the floor is yours.
Thank you very much, Dr. Marcelo, for the very kind introduction, and welcome everyone. My name is Christophe Casabon. I'm the Global Poultry Scientific Director for Ceva Animal Health. My talk today will be about the decrease of virus transmission thanks to vector ND vaccines. As we all know, today the poultry industry can be regarded as extremely efficient in terms of throughput, of highly affordable, high-quality meat or table eggs. And as you can see, nowadays the poultry industry is organized into even larger and larger complexes. And on top of that, usually the production is localized in some specific geographic areas of a given country. Just to give you an example, this is coming from the United States. And as you can see, in this small territory, you've got a very high amounts of poultry complexes, poultry companies, poultry houses. So this is a really highly specialized area for poultry production. The point is that, is there any Achilles heel into this model? Yes, there is. And it is about the ability of any virus introduction to quickly spread within and among these poultry houses. So just to give you an example, let's take this chart depicting a given complex, including 18 houses. And just imagine that this complex is suddenly hit either by a velogenic Newcastle disease virus, so this is for endemic countries, or by a lantogenic paramyxovirus type 1, so this is rather for ND-free countries. Whenever there is a suboptimal protection rate into this complex, then this virus will be able to get replicated and be shed to an even larger amount to the neighboring houses, and so on and so forth, until I would say invading the whole complex and being shed in the outside environment and further contaminate the neighboring complexes, including neighbors, other companies. So what can we do to tackle this issue? Let's look at the lessons we've learned from the recent COVID-19 pandemic. When a highly contagious virus is entering into a contact with a naive population, the spread is getting exponential, as you can see from this chart. However, whenever we find a way to break this transmission chain, for instance, by applying social distances, facial masks, vaccination, is becoming extremely interesting, because by breaking this transmission chain, as you can see, we manage to dramatically reduce the amount of infected human beings. So how can we translate that into the poultry industry and the challenges that it is facing today? So just take an example of a disease with a so-called reproduction ratio of 2. So this is the famous R value. Namely, it's a disease where one infectious chicken is able to infect 2 further chickens and 4 infected chickens, and so on and so forth. So when we look at the flock level, could we find a way to reduce this reproduction ratio figure to 1? Can we go further than 1, to go to less than 1? Is there any vaccine that is able to reach this? So I'm going to share with you the data that have been accumulated and where we partnered with Utrecht University specialists in order to calculate this reproduction ratio in chicken in front of Newcastle disease infection. So to calculate this figure, we actually need 2 figures. One is called beta, that's the actual transmission coefficient, so meaning how many infections per infectious bird per day, and you multiply it by the number of days that a bird is being infectious. So that's the infectious period, and R is the beta multiplied by T. So to do so, we used commercial broilers, and we used vector munendi as a vaccine. We vaccinated them at hatch. And indeed, we kept half of them for challenge, and we used the velogenic genotype 7 strain for that challenge at 42 days of age. And we kept contemporaneous vaccinated birds non-challenged, and they were brought together with the former one 8 hours later as contacts in order to mimic the real field case situation, where indeed a given part of a house, of a flock, is starting to be infected, and then the question is, what will be the behavior of the other birds in the same house towards this virus introduction? So this was specifically to address this point and to mimic as closely as possible the field situation. Of course, we need control birds, so no vaccine, no vaccination, and then half of them challenged and half of them being brought as a contact 8 hours later. So let's get into the results now. First of all, classically, that's the mortality rate, or I would say the survival rate And I would say, as expected, the control birds, so this is the red line, are dying rather quickly, which is just validating the severity of the challenge. And the orange line is the contact control birds, so the ones that were brought in contact to the former ones. So we can see that there was an efficient transmission of the pathogenic virus from the, I would say, the red group to the orange group. So the transmission was also efficient, since the naive birds that were put in contact to the inoculated ones, they also died within a few days. On the opposite, all vaccinated birds fully resisted the challenge. Now let's go into the shedding assessment. And to do so, we collected some oronasal swabs as well as cloacal swabs on the daily basis for 14 days duration in each and every of these birds. So every single dot represents one bird, one sample. In the unvaccinated group, so the red chart in the right-hand side of your chart, we can see a quite classical pattern where all the birds are shedding very quickly, massive amount of virus until they die. On the opposite, in the vaccinated group, in the left-hand side in blue, they shed to some extent, but very few, and even some birds don't shed at all. And this is valid for the oronasal swabs, but as you can see in the cloacal swab, it was minimal. So this is, let's say, the directly inoculated birds, so this is a quite expected outcome. We are much more interested into the contacts. So again, contacts brought together with the vaccinated inoculated or with the unvaccinated inoculated. And here again, for the red part, the contact birds, they got the challenge virus very efficiently and very quickly, and they also shed a massive amount of virus until they died. So just to mimic this transmission of the virus among birds, as I depicted in my initial drawing of a spread within a complex. On the opposite, and there is a statistically significant difference in the vaccinated group, as you can see, there is a much less amount of birds that are turning positive and that are shedding. And if they do so, they do it for a very short period of time. So now, if we translate this into figures, just to be more practical, we could calculate that there is a significant difference in terms of infectious period in between the two groups, as you can see from this chart. On top of that, the outcome is different. In the vaccinated, the outcome is the survival, whereas in the unvaccinated is the death. Secondly, the transmission coefficient is also reduced by a factor of 3 approximately. So that's already a very interesting outcome, since we found out that there is evidence that the horizontal spread of the infection is reduced by 3 times, which means practically that you've got more time to intervene, to slaughter, to cull these infected birds, to apply some reinforced biosecurity, and so on and so forth. And if we calculate the reproduction ratio, we see that in unvaccinated birds, we are getting a very highly spreading disease with a reproduction ratio which is above 3. And in the vaccinated birds that were getting vector munendi at hatch, we successfully brought this reproduction rate below 1, which is simply the evidence that the transmission chain has been broken by this technology. So just one more calculation, that's the probability or the likelihood that the introduction of a virus into a flock would result in an outbreak or not. As you can see, in vaccinated birds, theoretically, it's getting negative just because this R is below 1, whereas in unvaccinated, it's nearly 70%. So it simply means that, according to this calculation, most virus introduction would not result in an outbreak in a well-vaccinated flock, thanks to this strong reduction of the R value. So if we come back to this initial drawing, if we are in a well-vaccinated complex with vector munendi, whenever there is a virus introduction into a first house and there is, for some reason, some replication of this virus, there will not be any further spread across the complex, and there won't be either any further spread outside of the complex. So the take-home messages of this experiment and its practical consequences are the following. we are able now to aim at getting fewer outbreaks, less likely, and smaller outbreaks, less severe. So which means that by getting less between flocks and between farms transmission, by this way, the transmission ultimately is likely to be stopped, is likely to be halted. So if we try to bring some explanation to these strong achievements, we can just remind that this technology, and Vector-N in particular, it has been very well demonstrated and published, is strongly stimulating all different pathways of the immune response, meaning humoral immune response, mucosal immune response, and cellular immune response together. So that's probably explaining this outcome. So in 3 countries, this finding is very critical because for any authority, for any key opinion leader, we need preventing outbreaks or any further spread of a given outbreak, of a given disease. So this is a major achievement in reaching this goal. In endemic countries, remember that we will put 1 or usually 2 live Newcastle vaccines on top of Vector-N. So it's going to definitely further enhance this transmission reduction among birds. So that's the end of my talk. I'd like to thank you for your attention. And now let's give me the floor to Dr. Jaime Sarabia, who's going to share with us some real-world evidence of Newcastle disease control in Asia and around the world. Thank you very much.
Thank you very much for your kind presentation. And my name is Jaime Sarabia, Global Veterinary Services for Ceva Animal Health. During this presentation, we are going to talk about real-world evidences of improved Newcastle disease control in Asia and around the world. And I would like to start this presentation showing these 2 possible situations that we can find across the globe. The first situation is the one that we have in 3 Newcastle disease countries. In these countries, normally the birds are not vaccinated against ND, or they are just vaccinated with very light ND vaccine programs. The problems that we can find in these countries are the vaccine virus circulation, the rolling infection that can impact our performances, and in some cases very low titers. The second situation that I'm going to describe is the one that we have in endemic Newcastle disease countries. In these countries, the ND pressure is higher, and they are applying different vaccination programs, combining different types of vaccines, like live ND vaccines, kill ND vaccines, or vector vaccines. In this example, normally we can find, one of the problems that we can find is the field virus circulation and not uniform titers in our flocks, meaning that these flocks can be unprotected against Newcastle disease. This is one example I would like to show regarding awareness. In this study, 347 flocks were tested. These flocks were now Newcastle disease vaccinated. And if we take a look to the graph, we can see that 71% of the flocks are showing negative serology and 29% of the flocks are showing positive serology. And in these positive flocks, 11% of the flocks are showing really high titers, suggesting that these flocks has been challenged, showing some type of ND rolling infection, probably coming from live ND vaccinated neighboring flocks, maybe coming from Turkey or layer flocks that has been vaccinated with live ND vaccines. So live ND vaccine circulation from neighboring flocks and this kind of rolling infection are quite common in these 3 Newcastle disease countries. Another study that I would like to show is this one, where we compare different flocks vaccinated, some of them with Vector-ND and some others were not ND vaccinated. If we take a look to the graph, we can see that in any company, the titers of the flocks that were no ND vaccinated, they are showing much higher titers compared with the flocks that were Vector-ND vaccinated, showing that Vector-ND is able to reduce the live vaccine virus circulation in a very important way. Another study conducted in a 3 Newcastle disease country, we tested 339 flocks. These flocks, around half of them were vaccinated with Vector-ND and the other half were vaccinated with just 1 live Newcastle disease vaccine in the field. And we can clearly see that 0% of the flocks that were vaccinated with vector-immune ND were showing titers between 1,000 and 1,500. And 0% of the flocks that were vaccinated with vector-immune ND were showing titers above 1,500. But on the other hand, all the flocks that were vaccinated with live ND vaccine, we can see that 30% of the flocks were showing titers between 1,000 and 1,500, and 8% of the flocks were showing titers above 1,500. So, meaning again that vector-immune ND is able to reduce the live vaccine virus circulation between flocks. This is the last example coming from a free Newcastle disease country, where we monitor different flocks from 2017 to 2020. More or less, half of the flocks were vaccinated with vector-immune ND, and the others were vaccinated with another recombinant ND vaccine. And we can see clearly how flocks that has been vaccinated at every year with vector-immune ND are showing lower titers compared with the flocks that has been vaccinated with another recombinant vaccine. So, to summarize, vector-immune ND controls live ND vaccine virus circulation better than other recombinant ND vaccines. So now let's move to the second part of the presentation in endemic Newcastle disease countries. In this kind of countries, different types of vaccines are combined, like live ND vaccines, kill ND vaccines, or recombinant vaccines. In the example that we can see in the graph, this company was vaccinating the birds, the flocks, with live ND vaccine at day 0 and also at day 10 with another live ND vaccine. And we take samples at the slaughter age. And we can see that the titers are not uniform at all at the slaughter age. We can see that in the graph that many of the flocks are unprotected, are showing negative titers, and other flocks are showing high titers, suggesting that some flock has been challenged. So, live ND program does not provide uniform results, and meaning this could mean a lack of protection. In this study, in this example, we made two different groups of study. Some of the birds were vaccinated with vector-immune ND and 2 live ND vaccines, and some other birds were vaccinated with exactly the same program, but we added at day 0 1 kill ND vaccine. In this case, we challenged these two groups at 21 days and at 28 days of age with genotype 7b. In both groups, we saw that the protection was very high. We saw no mortality, 100% protection. And also, if we take a look to the serology, to the HI titers, we can see that in the group that have been challenged at 21 days of age, 10 days post-challenge, serological values are very similar and there are no statistical difference. And in the bird that we challenged at 28 days of age, we can see that 10 days post-challenge, both groups were showing very similar titers without any type of statistical differences. So really, just to summarize, there is no value of adding inactivated vaccine to vector-immune ND program. Both programs are showing very similar HI titers, and in this case, they showed exactly the same protection to the birds. So let's move to the last example in an endemic Newcastle disease country. In this example, we monitored hundreds of flocks from 2016 to 2021. Initially, this company was vaccinating the birds with another recombinant vaccine, adding some live ND vaccines. But because of the high titers and the number of outbreaks, this company decided to switch to vector-immune ND, applying exactly the same live ND program. And we can see clearly how the titers were going down year after year, and the number of outbreaks were going down too. So really, it's another example that vector-immune ND controls very good the field virus circulation and also better than other recombinant HVT ND vaccines. And I have these final messages. In free Newcastle disease challenge countries, vector-immune ND is able to reduce the lentogenic virus circulation, both in the vaccinated and not the Newcastle disease vaccinated flock. And in the endemic Newcastle disease challenge countries, vector-immune ND is able to reduce the Newcastle virus field virus circulation. So that's all. I hope you enjoyed my presentation, and I am available to any type of question that you have. Thank you very much for your attention, and have a nice day.
Thank you very much for the introductions. I'm very happy today to be able to share with you the epidemiology study and also the field pressure of infectious bronchitis that we did in Asia in 2020 and also in 2021. And in here, I would like to give you a brief about this epidemiology study is that we managed to did it in 5 countries, in 18 companies, and up to around 300 farms, 550 flocks, and we are able to samples up to around 946 samples for PCR testing, and also 9,000 and plus of this serology that we managed to test. And this serology that we were able to test was using BioCheck and IDEX test kit, depending on the test kit availability in different countries. And as you can see here, this epidemiology study that was done in these 5 countries, the most that we are able to get these informations are coming from Indonesia, with up to around 227 flocks, in Thailand up to around 165 flocks, in Taiwan 57 flocks, in Vietnam 53 flocks, and in the Philippines 38 flocks. And most of the flocks that we sampled in this particular study here today that I'm sharing with you are coming from broiler flocks. All right. So later I would like to share with you even more what our findings are. And here I would like to show you in a nutshell is in terms of the titles of the serology that we managed to tabulate and analyze coming from all the samples that we receive. And looking into different countries, and most of the time when we look into the flock health of this ELISA title, most of the time we look into just the GMT itself. And when we look into the GMT of these flocks, that is in terms of this infectious bronchitis, we can see most of it are looking actually quite normal, all right? Such as like for Indonesia, there is only like 49% of these birds are classified under IB suspected. For Thailand, was only like 24%, Taiwan's like only like 4%, Vietnam was 34%, and in Philippines was only 3%. And this suspected IB titles that we are looking into in this GMT were based on the different test kit. As what we can see here is that for BioCheck, we are setting a threshold of around 2,500 ELISA unit. For IDEX was around 2,000 ELISA unit based on the experience that we have, okay? But throughout the years, what we understand about IB is that when we're just looking at GMT, we might be losing some of the informations about the flock itself. And after many years of a study and also looking into the performance as well as the GMT and also the individual titles of these flocks, when we come to talk about infectious bronchitis, is that we also need to look into the individual titles of the bird itself. Here, just briefly, just to show you that if we look into the individual titles and we look mainly here, the maximum title of the flocks, and we can see the different pictures compared to GMT now, is that if you look at Indonesia, we have up to around 73% of the flocks are having possible of this IB suspected challenge. In Thailand, instead of 24%, we have up to around 42%. In Taiwan, we have up to around 32%, Vietnam 34%, and in Philippines, we can see there's up to around 81% that is possibly infected or challenged by this infectious bronchitis. Well, of course, we are not just going to stop here, just looking at the maximum titer itself. But as mentioned earlier on, we have this analysis that we actually look into much deeper, where we look into the deep this serology titer of the individual birds. In Ceva, we have developed this methodology where we actually will look into the these individual titers of the flock itself, and we set a threshold. In this case here, what we see is actually we set a threshold up to around 1,500 ELISA unit for this particular integrators that is using IDEX. And because of the nature of the disease itself for IB, which could replicate and also spread very fast, we assume that if a flock have up to around 20% and above of the birds with these titers above the threshold, then it means that all the birds around had been possibly been challenged too, okay? And why not less than 20? Is because if it's less than 20%, it's possibly due to some errors. It could be a machine errors or techniques errors and so on. So in this case here, this methodology is looking into a flocks. If we have 20% and above, we will consider that flocks as these IB challenge flocks. Okay, in this particular example here, all right, this integrator, they are using only the vaccines of Massachusetts and Connecticut. And what we see here in this about 26 flocks, we have up to around 9 flocks that is having this challenge, possible of IB challenge. The color of orange show that the flocks has actually have more than 20% of the flocks are having the individual title that is more than the threshold we set. Okay, so in these 9 flocks, we can see that when we match it together with the PCR results, there is up to around 5 flocks that is being detected with this QX-like virus. And this, when we match it with these flocks, we can see they are indeed being challenged with this individual title. Okay, so it is something that we try at this moment is that to look much deeper into the IB epidemiology study to know the situation of the flock itself in a much more deeper analysis. The next example that I would like to show it to you is another integrators which they're actually not only just using the Massachusetts and Connecticut, but also with the QX vaccines as well. And in these examples, we managed to do the study with the integrators and be able to collect up to around 65 flocks, individual titles. And then we try to use the same methodology again and to see how many percent of these flocks were actually being classified under this suspected IB, all right? And in this case here, what we saw is that even with this particular vaccine program, we are able to see there is still up to around 62% of the flocks had suspected IB challenge. Okay, so it means that not only just we have to look into the GMT today, all right, with this study, what we can see is that we need to also look into the individual titles of the birds and to understand even better on the overall flock health of the flock itself. Okay, so we also have these questions, whether this IB challenge has an impact towards the performance of the bird itself, the flocks itself. And we are happy that also we have managed to capture some of the data with some of the informations we have, is that we have a performance index together with the IB ELISA test titer, all right? And in this case here, when we put these informations in this particular graph, we saw that, okay, the performance index and also the ELISA title is almost across the whole ELISA range that we are plotting here, okay? But however, when we look or when we put the threshold, we assume, okay, in this case here, we assume that, let's say, 2,500 ELISA unit and above is actually an IB suspected challenge titers. When we put them into 2 groups, we can see that the groups that is having less than 2,500 ELISA unit, they have a higher in terms of the performance index, which is around 332. Whereas in the other group that is having above 2,500 ELISA unit, the performance index was 313. So when we compare these two, we saw there is up to around 19 points of difference. So indeed, this is actually something that we should really look into it, because this 19 points is very significant, I would say, and also it could means a lot in terms of the economic towards the producer itself. All right, and of course, mentioned to you in earlier on during our this epidemiology study, we have also taken some organ samples, and we actually sent it to in FTA cards to our laboratory in this Philaxia, SSIU Philaxia in Budapest. And the result came back, and we saw that in all these 5 countries, we managed to detect a different type of IB variants. In Thailand itself, we managed to detect QX-like and also Connecticut. In Indonesia, we managed to detect QX-like, 491-like, and also Massachusetts. In Vietnam, we managed to detect Q1-like, these IB variants. Whereas in Taiwan and also in the Philippines, we managed to detect these Taiwan 1 strains. So we see from these 5 countries, we receive a different these IB variants strands as compared when we compare with the results coming from each of them. Okay, so indeed, from what we saw in serology and what we saw in the PCR result, this IB infectious bronchitis is still a concern. It's still happening and is still causing some problems to the today's our productions or in these boiler farms. So it is very important that we really need to take the control of this infectious bronchitis. So next, I would like to pass my time to my colleagues, Dr. Marcelo, that he will speak about the control of this IB and with much better solutions. Thank you very much.
Thank you, Dr. Jessica. Well, now I'd like to discuss a few points that we should consider when it comes to vaccination against infectious bronchitis. But to illustrate this, I would like to start by this graphic produced by Professor Mattia Cecchinato from Padova University in Italy. In this graphic, he illustrated the dynamics of QX-IB field strain detection in Italy from 2011 to 2016. And you can see that the population dynamics go up and go down, but it's interesting to see how the vaccinations interfere with this dynamic. So we can see that the first type of vaccination that was introduced was the association of a Massachusetts vaccination given at day 1 of age and a 793B vaccine applied in the farms at 14 days of age. And you can see that with this approach, the dynamic of the population, the QX virus population, didn't change. It remained roughly the same. Well, later on, there was the introduction of a new approach. It was the association of the Massachusetts strain plus a 793B vaccine, in this case, Cevac iBird, and these vaccines were applied in the hatcheries. Interestingly, there was a sharp decrease in the detection of the field QX virus in the field, right? You can see this in the graphic. But just after that, it seems that the producers felt confidence to remove this type of vaccination, and after removing that, there was a sharp increase of the detection of QX virus again. Well, after that, producers reintroduced the 793B or the Cevac iBird plus the Massachusetts strain in the hatcheries, and you can see a very clear decrease in the detection of field QX strain in Italy. Well, this is a very nice explanation of what we could say displacement of QX-like virus in Italy. Well, but then we have to ask ourselves how these brilliant results can be achieved in our countries, in our farms, in our companies. How can we duplicate this? Well, let me try to answer this question by saying that basically there are 2 different approaches when it comes to vaccination against infectious bronchitis. Well, the first one is to use vaccine strains that are closely related to the field virus. And we can say here that vaccines that are produced from QX like virus or variant 2 or the BR1 vaccine for Brazil, for instance, or GA08, Georgia 08 strain for the United States. So we call it homologous IBV vaccines, and when they are properly applied, when they are of good quality, they provide good quality of protection. But there is also the smart combination of vaccines that will enlarge the spectrum of protection, and we call it heterologous strategy or cross-protection approach. And the most well-known association of vaccine is the association of a 793B, like Ceva bird, and a Massachusetts strain. This is by far the dominant approach all over the world. And there is one point that we have to consider. When there are several variants in the same region or in the same country, a cross-protection approach is needed, right? So after saying that, let me show you a few points. But it's not just any association, any mixture of vaccines that will induce protection. This protection has to be tested. This protection has to be demonstrated to the users. And here I'm showing a graphic, a table containing 43 different challenge studies with different strains that circulate in several different parts of the world. Among them, there are several trials with QX challenge strain, or Q1, or Taiwanese one, TW1, or the Malaysian strain, and some other variants. And in all of them, the association of Ceva bird plus a Massachusetts strain had extremely high levels of protection. So just to mention now, to reinforce my message here, Ceva bird has been validated using challenge with relevant strains that circulating today, that are challenging producers today in different parts of the world, including here in Asia. Right? But let's proceed. And I would like to come back and to say a few things about farm vaccination against IB. You remember in the first approach that Professor Cecchinato showed in that graphic, the first approach was to use the 793B vaccine in the farms at around 14 days of age. And it didn't change the dynamics of the QX population in the field. Then we have to ask why. And one of the reasons might be because of the farm vaccination. And I would like to show you this graphic. It is a publication, very old publication, almost 50 years, but it's still very relevant. These authors, Jordan and Arthur, they tested the survival of IB virus under different conditions, under different temperatures, under different hardness of water, under different chlorine. So I'm going to focus now only the survival versus temperature. There are several other parameters in this publication. I'll just focus on one of them, the temperature. And in this table here, I choose the temperature of 25 degrees Celsius. That probably represents the average temperature here in Asia, or at least in Southeast Asia. And we can see that at point 0, when the vaccine is prepared, the vaccine solution, we have 4.2 log 10 EID50 per ml. 1 hour later, this titration, this amount of virus has been reduced to 1.8 log 10 EID50. Well, we don't know how much is that. But if you transform this into numbers, you're going to understand how fragile this virus is. So at point 0, the solution had almost 16,000 EID50. In 1 hour later, this number had dropped to 63. In other words, this drop was 250 times from time 0 to 1 hour later. So we can understand that at 25 degrees, this survival rate of this virus at the farms is really, really very low. But we have also to consider another point. Today, there is a scarcity of manpower in the farms. And this is not a phenomenon only here in Asia, but in different parts of the world. It's becoming more and more difficult to find qualified workers to do a proper vaccination in the farms, right? And of course, if you don't have qualified workers, we are going to have even more problems related to vaccine application at that farms. So at the end of the day, it's natural to think of concentrating the vaccinations in the hatcheries, right? We could vaccinate in one place and the birds will send to different farms, but they will be fully vaccinated. And if the vaccination is properly done, they will be properly vaccinated throughout the production system. This is a good point, and probably today everybody agrees on that. Well, but the problem is that vaccinating and making sure that the vaccine will be well applied is a little bit different. It's easy to imagine that I'm going to prepare the vaccine, I will spray the vaccine to the day-old chicks, and these day-old chicks will be protected against any challenge. I'm saying that because today, about 90% of the hatcheries in the world will use spray vaccination regularly. So it's easy to assume that they say, okay, I know how to do this, I will do it, I will implement the vaccination in the hatcheries, and everything is going to be solved. Well, bad news is that it's not as simple as that. There are several points that we have to be aware. There are several critical points that have to be taken in consideration to really have a good vaccination. We have to think about the vaccination preparation. What kind of vaccine strains we are going to use? We have to think about the dose. We have to think about the reconstitution method. We have to think about the diluent that we are going to use. So the vaccine preparation is a very important step. But it's not only that, we have to think about the day-old chicks, their behavior. If they are well distributed in these boxes, if these chicks are active, how about the environment around them, the temperature, the humidity of that hatchery? So there are several points to consider also in terms of the day-old chick behaviors. But most importantly, and I would like really to emphasize this point, we need to be aware that the vaccine administration is critical to achieve a good immunization of these flocks. We have to think about the time to use the vaccine. As I mentioned to you, IB virus is fragile, so I have to make sure that that vaccine solution will be finished within 1 hour. So I have to make sure that to use proper equipment, but not only proper equipment, to make sure that the equipment is properly maintained, that the equipment is properly calibrated. So there are several points that I have to make sure that it works. So it's not only mixing vaccines and spraying the hatcheries. And finally, another critical point to make sure that the vaccination will be properly done is that the hatchery has to be monitored. This procedure has to be validated, has to be scrutinized by a well-known service program like the chick program. So if you have this type of program implemented in your hatchery to check every and each step of the vaccination, your chances are that you are going to have a very good vaccination. So never forget, vaccine preparation, day-old chick behavior, vaccine administration. Make sure that the hatcheries have chick program. This is the best that you can have to get a good vaccine application. But how can we measure that? Let me walk you through this graphic that I'm showing you now. And this was done by Ceva China. And it's a very interesting way that was developed by Ceva Animal Health to detect the vaccine that is replicating in the birds. So with this methodology, we go to the field, we go to the farms, we take tracheal swabs from the chicks at 4 days of age, and we send these swabs individually to the laboratory to detect the vaccine that is replicating in the birds. Well, you can see that in the 74 flocks that were vaccinated with Ceva bird plus Massachusetts strain, and they were under a chick program and a Ceva sprayer, most of the chicks was able to detect the vaccine strain in the respiratory tract, in the upper respiratory tract at 4 days post-vaccination. However, if you see at the gray bars, you're going to see that with competitors' vaccine and using other type of equipments, and probably without a chick program or any program that is similar to this, you see that the detection of the vaccine virus in the birds is very erratic. It's not homogeneous at all. In some cases, you can detect 100%. In some other cases, you don't detect anything. So, and this is not what you want for your production complex. You want a homogeneous vaccine take, and the first flock of the day to the last one, the vaccination will be done with the same criteria, with the same quality, right? But now I would like to come back to the first slide and try to answer the question that I proposed before. What could we do to have the same type of results as was shown by Professor Cecchinato? Well, I think I have answered this question in my presentation, but the best solution is to associate well-known vaccines like Ceva bird, a 793B strain, and a Massachusetts strain applied at day of age in the hatcheries by well-maintained, by well-calibrated equipment to make sure that the distribution of the droplet is well done, to have this hatchery audited regularly by chick program specialists, and by assessing the vaccine take at around 4 days after vaccination. With that, I'm absolutely sure that we are going to be able to replicate these findings in Italy here in Asia. I'm absolutely convinced that we are going to be able to displace any type of field virus that today is circulating or challenge your production facilities. Well, now we are coming to the end of this presentation, and I would like to leave here some final considerations. But before listing them here, I hope that you have enjoyed this 1 hour that we spent together. And again, I would like to thank you all to honor us with your presence. This is for us the most important point, right? But I would like to deliver 3 messages here. First, Newcastle disease and infectious bronchitis are among the disease that cause the more economic impact to producers. And this is not only here in Asia, in other regions as well. If you go to Brazil, if you go to the United States, if you go to Europe, they always will mention infectious bronchitis. If you go to Middle East, they are going to say, okay, Newcastle disease, infectious bronchitis. And as I mentioned during my introduction, today we have another complicating factor here in Asia. H9N2 has spread throughout the region. We have identified this virus in several different countries, and definitely the presence of this virus complicates or aggravates any respiratory problems in the flocks. So we really need to pay attention. We really need to make sure that the flocks are well protected against Newcastle disease and infectious bronchitis. But how can we achieve that? Well, as I mentioned before, the use of vaccines that induce strong protection and contribute to reduce the field virus circulation, as it was mentioned by Professor Cecchinato, as shown by Professor Cecchinato in that slide that I just showed to you, along with strict biosecurity procedures, are the key points to successfully control this disease. So I would like to repeat one more time, the important message that I would like to leave here. When you think about vaccines, when you think about services, always keep in mind high quality of vaccines. The reference vaccines in your countries. There are reference vaccines in your regions like Vectomine D, like Ceva bird. These vaccines have been tested under laboratory conditions and field conditions, and they have shown excellent performance, whatever the field pressure is, whatever the IB virus that is circulating in your areas. So you can trust in these products, you can trust in the company that is make them available to you. But not only this, you have to make sure that these vaccines are well applied. As I mentioned to you before, a well-applied vaccine by well-calibrated, well-maintained equipment, and most importantly, checking whether these vaccines are replicating the birds, this is critical. So if you have a tick problem in your hatcheries, this is a good step for making sure that these vaccines are well applied. And finally, make sure that you monitor these vaccines. Make sure that you monitor the vaccine take. Make sure that you monitor the seroconversion that will be induced by these vaccines. By following these 3 steps, good vaccines, good application, and proper monitoring, I'm absolutely sure that you're going to be successful to control this disease in your farms, in your regions, in your countries.
Dr. Marcelo?
Yes, I can hear you.
Very great. Okay, here we have a few questions from the audience. First is coming from, let's see. Okay, there's a question once from Adrian Ding. All right, so how much mutations variant does ND paramyxovirus happens, and is the homologous vaccines much more effective?
That's a great question. Yes, of course, this virus mutates, but we have to keep in mind that there is only one serotype. Make a long answer short, only one serotype. And there is a misconception that genotype matching vaccines will work much better. There is a consensus among the researchers that the protection will not increase. There is a slight reduction in reexpression of the challenge virus when these vaccines are used in mass birds. When they are used in real life, when they are used in broilers with maternal derived bodies, they will face the same shortcomings of conventional live or conventional kill vaccines. There will be interference. That's the reason why the vector immunity is superior to this type of technologies.
Okay, thank you, Silo, for that. Quickly, there's one question from Vorachai. All right, so Vorachai is asking that it is clear that Vectomine ND is better than other vector ND vaccines. Do we have more information about the vaccination that have ND inactivated with the vector vaccines?
Yeah, thank you for this question, Dr. Vorachai. What we are doing now is to demonstrate that vector immunity alone does not need that we call the help of ND-Q vaccines, because the tech is so strong that it does not need to add this type of vaccination. And there is one very important point to do this. If you are going to use vector immunity, companies might go for novel vaccination. And if you have to use Q vaccines along with another vector ND, you cannot go for that. That's the reason why we have demonstrated that vector immunity alone is as protective as vector immunity plus a Q vaccine.
Thank you, Marcelo. There's one quick question. Where can we find this data that was mentioned by Christoph on the transmissions?
That's also a good question. It's an open access publication, so it's very easy to find. Just type on the web, Vectomine D reduces the transmission of Newcastle disease virus. And just browse, and you're going to see an open access, and you can download the publication. I do recommend you to read it. It's extremely interesting.
All right, thank you. One last question, quickly. There's one question for Ichiro. Okay, both the vaccines are same concept of the vector vaccine, but different result is a gate. What is the difference in Vectomune? Was it the F proteins or something? Yeah.
Thank you for this question, Dr. Nakayama. Yes, there are differences among the vector and D vaccines, and they are basically because they are different constructs, and different constructs will have different biological properties. One will replicate faster than the others, one will induce faster protection, and so on and so forth. And basically, this is due to the insertion site to the parent Barrett's disease virus or HPT that's used and the promoters that are used during the construction of these vaccines. Thank you. To this question, yes, indeed there are differences among different products.
All right, thank you. So we have finished our time for the Q&A. So for anyone who is interested to ask more questions, we posted here, there's an email address, questions _Ceva_vconnect@ceva.com. All right, so you can write to us and we are very happy to be able to answer to you. All right, thank you very much. Thank you, Marcelo.
Thank you to everyone that took the time to watch this presentation. And see you tomorrow, guys, at the same time.
All right, see you guys. See you tomorrow.
Thank you very much.
Bye.